Hello. So welcome to this new video. So in this video, we are going to see how we can integrate the AWS forecast into, let us say, production grade application or a full stack application. So for this, what we have done is that we have designed a inventory management system using Django React, and then integrated the AWS part into the part backend, so that you can completely train models within just click of a button, deploy it within the app itself for each product you want, and then uh, generate the forecast for that particular product using the trained models. So the problem statement which we are trying to address here is that so business often face any challenge of predicting the product demand. So that are usually done by statistical methods or other forecasting methods through the mathematical operations. But since they have come into picture and we can easily deploy or access these cloud solutions as well, then why not go for these solutions to give us a better idea and more tailored solution to each of your let us say product or type of products you want to generate forecast for. And it all happens with just a click of a button, so you don't have to really do much calculation or hire specific people for you to generate these forecasts, etc. And again, with these kind of industries, there's usually a problem of overstocking, understocking, and other things. And again, inventory management and storing ideal inventories cost for a particular company. So in order to like overcome all these things, we generally go with forecasting as an option to help us predict and maintain a minimum inventory as much as possible. Now, the solution which we have developed is an automated forecasting solution, where you are allowed to train independent forecasting model for each types of product or each product itself, and then you can generate the forecast for, let us say, the next 30 days. So, in order to build this particular application, we have gone with Django REST API backend, and then the React frontend. And for the forecasting part, we have gone with Amazon SageMaker and AWS Forecast to train and deploy models in AWS. And we have also like create a versioning system within the app itself for you to track what was the latest model you have trained, what are the metrics for that, and what are all the previous models you have trained also, so that you can compare how whether the newly trained model is actually better than the previous one or not. Now, in order to design this particular app, the main components is the React UI, then the Django REST API part, and in the SageMaker we are using the Auto ML version 2. And for storing all the database or even the data set or the model itself, after training we are using the S3 bucket in the AWS. And for database we are currently going with the Postgres SQL database. And these deployed models are actually real-time SageMaker endpoints that are deployed in the AWS. Now, how the entire workflow which we have designed is that, so first, admin selects any particular product, and then the dataset which we are going to prepare will have a similar format of item ID, then the timestamp, then the target value which we want to predict. Then what happens is that we upload the file to the S3. Then we create an AutoML version 2 job, that is nothing but the AWS forecast, so that they are actually integrated into the AutoML part. Then after starting the forecasting in the AutoML, we determine the best model out of the selected models and deploy that particular model into a real-time SageMaker endpoint. And from there we just use that particular endpoint and store it in the database for us to use, and then use that particular deployed model. Now I will again show you in the UI aspect as well. So this is this very simple UI which we have created for this proof of concept app. So here in the inventory admin, so you should be able to see the different product names and the category it belongs to, and its MRP, buy price, and the stock left. Then in order list page, so you are basically going to get the list of orders that has been placed so far. And here we just generate a random order id, the date at which the order was placed, and the total amount, and the amount of quantity and the price at which it was sold is also noted over here. Now you can also add the order here for the particular product. So you can select the product, quantity, unit price you are selling it, and the discount from of the unit price if you want to give any. And then you can add multiple items, and even remove any rows you want as well. And you can just click on create order to for it to add that particular order onto the database. Now in the inventory admin panel, so once you have registered a product and have let us say more than 120 or 150 orders, um, or 150 days of basically data set rows you have, then what you can do is that you can start generating the forecast. So why we require specifically 150 is that, so for us to train the model in a good manner and get good result, so it requires at least 2 to 3 times more data. So that is why, because our forecasting period is 30 days, we are going to sticks to the safer side and generate 5 times data set for the model to have enough data to give us good predictions. So once you have the data with you for 150 days, then you can just click on this train forecast button for that particular product, and it will just train the model. So this again usually takes up to 20 to 30 minutes, again depends on how much data you have. So the larger the data you have, the larger time you need to train the model. So once you just click the data, it will automatically start the workflow in the backend, and connect to AWS and start the entire workflow which we just saw in the presentation. Now, after clicking this train forecast, it will take 10 to 20 minutes in my case to train that particular model. So let us just do that. Now the model has been trained, so you will get a alert like that, and you can also see the trained model as well. So the currently model has been trained at this particular time it finished. So the forecast which we are generating is for 30 days, and these are the metrics for that particular model it generated. And this is the model name which we are storing it in the database, and you need that model name to be uh, uh, to access those particular endpoints in the AWS as well. Now, once you click on view model, you should be able to see that result. Now, after that, you can even see the forecast it generates for the next 30 days. Now, if I click on that particular button, you will be taken to this particular section where you should be able to see the forecast it generate for that particular product. So you can see that it clearly understood there is some pattern, and it is trying to predict that particular pattern for the next 30 days. So this is how you can design the entire app and integrate the AWS part into the mix, so that you have an entirely automated full stack application with AI forecasting integrated into the app. Now, if you see the result which we actually got for the trained model, so the best candidate or the model which turned out to be the best was a model architecture known as CNN plus QR model. And the average weighted quantile loss, it is a metric or loss function which we monitor. We got a 0.0135, and the root mean square we got was 3.96. And in comparison to other models which it considered uh, was Arima, Profit, etc. So CNNQR performed the best out of these slots. And then the result we are able to get instantly using the deployed endpoints which we have generated. So this is the entire proof of concept which we developed, and because we had introduced the ML ops into the mix, so what it really helps us do is that once you train the model, you should be able to version control the model. and automate the entire SageMaker deployment as well, so that you can deploy multiple versioned models and test out which one works best for you as well. And because we are storing metrics for each version, you can easily compare which model is better based on the metrics. And because again, we are so deploying it in different instances, we can do the A/B testing as well, thereby seeing what the user feels, and getting the result for the unknown data which we have. Because sometimes, the model may give good results on our dataset, but on the newer dataset where there is less slight shift in pattern, etc., so the model might perform bad in that particular case. So in that case, we can shift to a older version model that might perform much better than the newer model which we have trained. And we are storing all the artifacts in our application as well. So that's it for this particular video. So hope you got an idea of how to develop an entire full stack AI application with automated forecasting with the help of AWS services. So again, if you want to build such applications, or if you want to develop your own proof of concept or MVP, feel free to reach out to us by mail at contact@codersarts.com. Or again, you can reach out through our socials as well, either through YouTube or through LinkedIn as well. So that's it for the this video, and see you in the next video.